Have you ever wondered how those polls work? You know, the ones that say they know how an entire country is going to vote just by asking 1,000 people? Or how a company seems to know exactly what you want to buy, sometimes even before you do? Well, the secret to all of this is a really powerful idea called sampling. And today, we're going to break it all down. Okay, so let's just tackle that big question right away. How on earth can a tiny group of people, just 1,000 or so, actually speak for millions? I mean, it sounds like some kind of magic trick, right? But it's not magic, it's all about a really clever approach using statistics.
And that approach, that idea, is called sampling. You see, instead of taking on the totally impossible task of talking to every single person, we just pick a smaller, more manageable group to represent the whole. But, and this is the important part, the real secret sauce is in how we choose that group.
So, okay, why even bother with sampling in the first place? Well, the answer really just comes down to one thing: practicality.
I mean, let's be real. It's pretty much impossible to survey an entire population. It would take forever. So sampling is this elegant solution. It saves us a ton of time, a ton of money, and a ton of resources. And the amazing part is, it can still give us a surprisingly accurate picture of the whole group. That is, if it's done right.
All right, so it's time to open up the researcher's toolkit. Let's get into the how. We're going to start with two of the most fundamental, kind of the bread and butter methods of sampling.
So first up, we've got simple random sampling. And honestly, it's exactly what it sounds like. Just imagine putting every single person's name into a giant, enormous hat, and then just drawing a few names out. That's it. Every single person in that whole population has a completely equal, totally unbiased chance of getting picked.
You know, the source material really puts it perfectly. It says, no sequence, no system, just selecting randomly. It's basically sampling in its absolute purest form. But just because it's pure doesn't always mean it's the most practical way to go. Okay, so next up, let's add a little bit of structure to the mix. This is called systematic sampling. And here, we're not just leaving everything up to pure chance anymore. Nope, we're going to use a simple repeating rule.
So, how does this actually work? Well, it's pretty straightforward. First, you line up everyone in your population. Then you pick a random starting point, and from there you just select every, say, third person or every 10th person, or whatever number you choose. It's a really simple way to make sure your sample is spread out nice and evenly across the entire list.
Okay, you ready to level up a bit? Let's get into two more advanced methods, stratified and clustered sampling. Now here's the thing. They both use groups, but they use them in really different ways. And honestly, this is where a lot of people get confused. So let's break it down nice and clear.
Okay, first, let's talk about stratified sampling. What you do here is you slice up the whole population into these meaningful subgroups. We call these subgroups strata. So, for example, you might group people by different age brackets, or by gender, or maybe by what region of the country they live in.
And here is the absolute key. After you've made your groups, you then take a random sample from inside every single one of those groups. You see why that's important? This is how you absolutely guarantee that all of your important subgroups are properly represented in the final sample.
Okay, now let's switch gears and look at clustered sampling. With this one, you also divide the population into groups. We call them clusters. But, and this is a big but, the goal here is totally different. With clustering, each group should ideally be like a mini version of the entire population. You know, a diverse little pocket. Think of a single city block that has a mix of all the different kinds of people you'd find in the whole city. And this is the big difference. Instead of taking a few people from every group like we did before, here you randomly select a few entire groups. And then every single person inside those chosen groups becomes part of your sample. See the switch? Okay, I know. They can sound pretty similar, right? This is definitely where it can get a little tricky. Both methods use groups, so what is the real difference? You know what? Let's just put them side by side so we can see it clearly.
And here it is. This is the absolute core distinction. I want you to let this sink in because it's the key. With stratified sampling, you select some individuals from all of the groups. But with clustered sampling, you select all of the individuals from just some of the groups. It's such a simple way to remember it, but it's a really powerful difference in how you do the research.
So there you have it. We've got our four main sampling tools in our toolkit: simple random, systematic, stratified, and clustered. But how does a researcher know which one to actually use? Well, it's all about making the right choice for the specific job you're trying to do.
And really, it all boils down to three key things. First, the nature of the population you're studying. Second, what your research objective is, what are you actually trying to find out? And third, you got to be realistic about your available resources, things like time and money.
And look, this is why getting it right matters so much. Choosing the right technique isn't just some minor detail, it is the absolute foundation of your research. If you get it wrong, your results could be completely meaningless. I mean, just look at the infamous 1936 Literary Digest poll. They predicted a massive landslide victory for the wrong presidential candidate, all because their sample was just deeply fundamentally flawed.
So, here's my challenge to you. The next time you see a poll or you read about a new study, don't just jump to the results. Stop and ask yourself, wait a minute, how did they choose their sample? Because now you know the how is every bit as important as the what. And understanding that, well, that's a total game changer.